So for our data sets, we have about 10 data sets in total, and they are going to hold valuable information for us. So the first data set I want to look at is called stock underscore symbol underscore name. And as you can see on the screen here, it basically contains the stock symbol and the company name that is related to the stock symbol. So there are about 91 stock symbols or about 91 companies in here. And I'll definitely add more as I become more and more interested in companies I've never heard about and they have a stock on the stock market. So this file is the basic starting point for me. So everything here, everything that you see here was typed out. So WBA, Walgreens Boots Alliance, 91 stocks, all of that was typed out by me. I looked up the company name and then went on from there. And like I said before, I'm going to add stocks, but I have to keep in mind that the more stocks I add will increase to a longer runtime to the other programs that I have. But that's basically it for this data set. Nothing very too complex. It's just basically me writing out the stock symbol and the company name associated with it. So the next data set I want to look at is called date underscore table. This data set contains records starting from the 1800s all the way up to the year of 2025. The unique identifier is of course the date because it'll only appear once, but then we could also break down the date into multiple columns like the year, the date, or even the quarter it's in. The main reason for this table is mainly so for like a gateway table. If I need to make a connection between two tables but I can't do it directly, then this date table should be able to help me connect those two tables together as being some type of bridge. So you can see the file has finally opened and we have the columns of date, year, month, date underscore month, and day. For the most part, they should be self-explanatory except for date month. That's just basically a different format. I just basically put the wrong column name for it, but that's not really a big deal. We can always go back and rename it if anything. And you can see here, we start from the 1816 all the way up to December 1st, 2025. And like I said, this data set will act like a bridge between two other tables in our database diagram. There's nothing really else special about this data set, so we could move on to our next one. On to the next data set, and for this one is mainly used for our time series analysis or when we are going to try and predict the future closing price of a certain stock symbol. So this data comes from data.worldbank.org. As the file downloads and opens from worldbank.org, I'll tell you what this file contains. So it contains all of the countries and their gross domestic product for every year from 1960 all the way up to 2018, if that data is available. But in my case, I don't need to see all the countries. The only countries I am interested in is the United States, and they have a country called World, which is basically all of the world GDP put together and added as one. Basically that. So we are going to use those two columns or those two rows because we have a bit of a matrix table here. And this data set actually does get cleaned up and looks a little bit prettier at the end. So we are only going to take two columns and we are going to have their GDP data from 1960 all the way up to 2018. But first, this is what the original file looks like when it has not been cleaned yet. So this is what the final data set looks like. So as you can see, we turned that matrix table and we transposed it. So now the year or those year values become the rows and vice versa for our country. So we have the columns of year, United States, and world. And you can see that we have data from 1960 all the way up to 2018. I only have to do this data cleaning process once because I have another file that contains macros that will clean the original GDP data file and turn it in to make it look like this. So whenever the website databank.org comes out with new GDP data, I can easily download it, put it in this file location, and run my macros for it. Alright, so now we are moving on to the more interesting data sets. But before we get into that, I'll talk about the first library I used in Python to grab our historical stock data. So one of the goals with this project, or something I wanted to accomplish, was to be able to web scrape. And web scraping historical stock data proved to be a little bit more challenging than I thought it would be. To make a long story short, I basically came to the conclusion that for me, and maybe for other people, that it's really hard to pull historical stock data from the web because there's multiple variables. Well, the main one being that you need to be able to search for different date range. But upon my research, I was able to find a Python library called yfinance. With this library, it made this project a lot more easier because now through Python, I was able to search for any stock symbol and grab historical data based on the date range I gave it to. And with this information already being in Python, I could then turn the historical stock data into a data frame and export it as a CSV file or even a text file. So you can see here on the screen now that this library was created by Ran Arausi. He is also the same person who maintains this library as well. You can also see that in his demo coding that from the first 5 lines, we have all the information we need for this project. Well, a majority of it. So with his library, all you would have to do is enter in a ticker symbol and then select the period or the date range that you want. You can have it from a 7-day period, 2-week period, a month, 3-month, even the maximum period, which you see on the screen now. So all we would have to do is create a loop that looks at our stock symbols in our stock symbol file and retrieve the historical data for each stock symbol in that file, and then we would just have to output it to a data frame. Now that we have taken a look at the yfinance library, we are going to create our first data set using this library. With the programming, I'm going to try my best to try and explain everything clear and concise, but if you have any questions, feel free to contact me. Also, it doesn't have to be just about the programming, it could be about other sections covered in this video series. With our first box, we are going to import the yfinance library and the pandas library. We already know what the yfinance library does, but for the pandas, we are going to use it to read files in and create a data frame with the data that we pulled from the yfinance library. In our second box, we are going to create a variable called stock, and this will use the pandas library to read in our text file. Our text file is stock underscore symbol underscore name, and this is the data set that we looked at earlier where it contains all the stock symbols and the company name behind it. With our file now being read in, we could start to try and create our loop. So in the third box, we are going to create another variable called df2, and this is basically an empty data frame. We create an empty data frame because within our loop, we are going to create another data frame that will hold the current stock symbol history, and then that data frame will append to our data frame on the outside, which is called df2. If we didn't have the variable df2 on the outside of our loop and only had the df variable on the inside of our loop, we will only see the last stock symbol history. So whatever the last stock symbol in our stock underscore symbol underscore name text file is, when we go to look at the df data frame, we will only see that last stock symbol. So let's say, for example, if it was WBA and we know we have multiple stock symbols in our original file, the last stocks or the only data that we are going to see will be historical data for WBA or Walgreens. With that being said, we can now take a look at the first line of our loop. So we have for symbols in stock underscore symbol, and I'm going to explain this first line quickly and what it means. So it's saying that for every stock symbol in our original file that we loaded in, we are going to perform these steps. So let's start with an example first. So in our data set that we loaded in, stock underscore symbol underscore name, the first stock symbol in there is WBA. So for this loop, WBA is up first, and for WBA, we are going to create a variable called SS equals YF.ticker, and then we have the argument called symbols. So currently we are on the first stock symbol, so it's going to look at WBA. Once the YF ticker function finds the stock symbol, we then will create another variable called his. His is a variable that will find the historical data for our current stock symbol. We also have the option to choose different time periods. So in this first loop, we are going to look at the max time period. Basically, from when the stock first started trading, to the current day. So today is December 3rd. So Walgreens, whenever that stock first became public, all the way up to December 3rd. After that, we are going to create a data frame, and it is going to hold the historical data. Now, with our historical data, the one thing about it is that when you search for it on the Y Finance library, it doesn't tell you which stock symbol you're looking at. So let's say if we search WBA, we could of course see all the historical data for WBA for each and every day, but it won't tell us the stock symbol. We would just have to know from previous lines of code which stock symbol we are looking at. So this is why in the next line of code where it says df stock underscore symbol equals symbols, this creates a column in our data frame that will add the current stock symbol next to the historical data in our data frame. Once that stock symbol has been added to our df data frame, we will then append the df data frame to the data frame on the outside, which is df2. Append basically means just to update. So with the first stock symbol done, this process is repeated for every stock symbol in that dataset file that we loaded in. Once all these stock symbols have been found and they have the historical data, we would then export it to a CSV file called stock underscore history.csv. As of now, this data set for the first loop that we created contains about over 600,000 rows. And like I said earlier, more stock symbols are going to be added. And with the addition of more stock symbols being added, it's going to result in more rows. In our fourth box of coding, it's basically the same concept, but we are going to look at the historical data for the stock symbol at a 1 week period. So you can see period equal 7D. So that means one week or 7 days. And the file that we are going to export it is called stock history underscore one_week.csv. Another thing to note is that within our loop, we have a print statement. Print in parentheses symbol. So once this loop is completed or just about going to be completed, we are going to print the stock symbol. That is the last step. This step is here for because when I run the code in the command prompt, I would like to see where the progress of the coding is at. So which stock symbol is it on, or which stock symbol has it complete. And you can see in the output that stocks in original file, and then you have Walgreens was complete, Ali Financial was complete, Visa was completed, so on and so forth. So when the command prompt comes up, I have a good understanding of where the coding is at or which stock symbols have been completed. And to finish up the programming, we have a final print statement that shows us, that tells us that both files have been updated, and we can move on to the next step. So anytime the program is completed, our file should be updated to the current date that the program was ran, and we should also get this print statement at the end. So this is what the final data set looks like. You have the date, adjusted close, dividend, high, low, open, stock split, stock symbol, and the volume. And we're almost approaching over 700,000 rows. One last note, this is the largest data set out of any of the data sets we are going to look at. The next script and data set we are going to look at, I would say, was probably the most difficult one out of all the data sets I had to create. I've never done any type of web scraping using Python, so everything that you see here is all new to me, and I had to create by researching or finding out what each function do or how can I get my desired results. So the next project that I build out that has to relate to web scraping using Python again, the second time around should be a lot easier, or if not, I could just refer back to the scripts I have here. This script is called Final News Scrape, and the goal of this script was to pull the headline, pull the link to the article, and pull the date the article was published coming from the Google News website for each stock symbol in the file we loaded in, which is called stock, which is basically our stock symbol name file. So this is the website we are going to pull the headline, the link to the article, and the date the article was published. And we need to do this for every stock symbol in our original file that we loaded in. This is the best place to pull those articles because the Google News aggregates different sources together and outputs them as one for whatever news you search for. So in our case, we looked up WBA stock, and you can see that there's different publishers. You have Simple Wall Street, then you have Yahoo Finance, then Seeking Alpha. This is good because we'll have a wide range of publishers and articles coming from different websites. But like I said earlier, we need to create a script that will automatically search this link or search the Google News and grab all those headlines for every stock symbol that we have in our file. Let's get back to the coding so I can explain to you what I've created. Let's start with the first text box. So the first three libraries and packages we are importing are the first ever time I've used those libraries and packages. But importing pandas and NumPy, I've used them plenty times before, and we already seen pandas used in one of our previous data sets. So with the first library and package we are importing, we are going to use urllib.request importing URL open as urec. From my knowledge, what this will do is that it will open any URL link within Python. The next line, from BS4 import beautiful soup as soup. This basically will help us scrape data from the web. So whatever link we have, we'll be able to pull information from that website or link we are currently using. Next, we will import request as R. This is basically going to help us make HTTP requests in Python. The main thing in our case is to inspect data from our web link. Then finally, we are going to import pandas and NumPy. This is mainly for data manipulation, and as you've seen before with pandas, we are going to be creating another data frame. Alright, so with that out of the way, we can move on to the second box of coding, and it's basically what we've seen before in our last script. So we have the variable called stock, and it's going to read in our stock underscore symbol underscore name file. This file, of course, contains all our stock symbols and the company name behind it. So let's get on to the more interesting part. So in our third block of coding, the first thing that we do is that we create a variable called I, and we set it equal to 0. The reason for this is that I only want to look at the first 5 headlines that the Google News webpage returned for each stock symbol. Once we have 5 headlines for the stock symbol, I then want this script to move on to the next stock symbol and repeat the process again. In the second line, we have, of course, our empty data frame. Think of the variable b as a tray, and we are going to be adding things on top of that tray within our loop. So on to the next line of coding, and you can see here we are going to begin our loop. So for symbols in stock.stock underscore symbol, we are going to perform these steps. And with the third line of coding, we've seen what that looks like already. We're basically saying for each stock symbol in the file that we loaded in, perform these steps. So beginning of the loop, we are going to create a variable called URL, and this is going to hold our template link to search for different stock symbols. So with this link, I've modified it slightly so that the current stock symbol it's on, the link will know to look for that stock symbol news or any news that came out for that stock symbol. There's a part in the link where you're able to search for anything on the Google News web page without even going to that web page directly. You could type it in and it'll take you to what you searched for. The part where you see Q equals symbols plus stock, that is where we modify the link. So basically what the Q is, from what I believe, basically means query. So what are we searching for with this web link? So with this modified link, the current stock symbol that the loop is on will search for stock news for that specific stock symbol. Let's take an example. Let's do an example. Replace symbols with WBA, and that's basically all these symbols is doing in this script. Because we have this in a loop, we don't need to manually search each stock symbol news. Alright, so hopefully that clears things up and we can move on to the next line of code. For the next couple lines of codes, we are going to open the web link, read it, and then close it. For uClient equal urec parentheses URL, that is basically the URL link we are requesting to see or requesting to get data from. The next line, HTML equals uClient.read, we are basically reading the data from that web page. And then uClient.close should mean that we are closing that web page. The next thing we are going to do in our loop is that we are going to parse that HTML web page that we searched for earlier. We are going to use a HTML parser to grab all our data, or to search for all our data as well. So now that we have parsed our page, we are going to look for key information to get our desired results. That's basically the headline, the web page link, and the date the article was published. So let's start with the table variable. So what the table variable is going to do, it's going to find within our web page all the H3 tags. Next, we are going to look for an attribute called class, and it has to be equal to this string of text that you see here on the screen for our H3 class. The string of text that you see here is basically our attribute value, and this is the headline coming from that web page. Alright, for the next line where we create the variable called table2, this time we are going to be taking a look at the A tag with the attribute called class, and then the attribute value of the string that you see here on the screen, which is vdxfz. This basically holds our article link, and we are going to use that later on in our loop, in another loop, to grab the link from that tag. For the next variable called table3, we are going to look at the tag called time, the attribute of class, and the attribute value of the string of text that you see on the screen, ww6dff, and so on. This is going to give us when the article was published. Alright, so for those 3 lines of coding that I just went over, it is going to try and find all those tags, class, and those attribute values where they have a match. And then it's going to hold it in its respective variable. Alright, before I move on any further, I want to show you what the data in those table variables look like. So you can see here highlighted in the red box is what a similar example to what our table variables data will hold. Very messy, and we don't need all that information. We only need to get the headline, the article link, and the date it was published. And you can see below on that next line of code that with a simple text function, we are able to grab only the headline from that web page. But this example was more so to show you how our data looks like in those table variables. So it's very messy, and we have to do a bit of data manipulation or data cleaning to get our desired results. Alright, so we have a nested loop now that we are going to explain. So the first thing we have is while I is less than 5, we are going to perform these steps. And by the way, the reason that we have I less than 5 is because I want to look at the 5 most recent headlines from the current stock symbol. How the Google News webpage have their search engine set up, you see the most recent articles published first. So every day when we run this program or script, we are always going to get the most recent results if there were any published for that stock symbol. So we can move on to the next line of code. So we have a variable called headline, and it's equal to table with the index of I, and we are going to retrieve only the text. If you remember, we set I equal to 0. So this is the first instance of this loop running. So we are going to select the first headline we see. Once we have that, we move on to the next line of coding where we have another variable called link. And this is going to look for table 2 for the index of I, which is 0 in this case right now. And we are going to use the get method to find the attribute of href, and that is going to return our article link. So when we click on it, it'll take us directly to that web page. Then we will create another variable called date, which looks at table 3 with the index of 0 in our case, or the index of I, and it's going to use the get method again to return the date the article was published. Now that we have our variables set up, we could create our data frame. This is another data frame that we are creating, and the index for it will be the symbols or the stock symbols. We then are going to create our columns for the data frame we just created, and set them equal to the variables we just created previously as well. So in the first line where you see a stock underscore symbols, we set that equal to the current stock symbol that we are currently on. For the next one, for headline, we are going to set that one equal to headline. And then for link, we set that equal to a link template and then plus the link from our variable from earlier. When we had used the get method to pull our link, the link on the Google News page doesn't include the full link. So this template here, when combined with the link variable, will take us directly to that article webpage. And then lastly, we have a column called publish, and we are going to set this equal to the date. So this is the date when the article was published. Once all of this information has been stored in our A data frame, we are then going to append it to our B data frame, so where this information is continuously updated. And all of this represents one row of data. So that's why in the next line where we have I equal I plus 1, we are going to move on to the next index or the next I. It's then going to repeat the same process for the current stock symbol until it reaches I equal 5. Once I equal 5, we are then going to reset I back to 0. So that is why you see I equals 0. And then we are going to break that nested loop and start the process again until all stock symbols in our original file that we read in have been completed. And lastly, we have a print statement that tells me which stock symbols have been completed. Because we are using internet connection for this script, this program takes a little while to run. It takes around 30 to 45 minutes to run, depending on how many stock symbols we have and our internet connection speed. This is why I added that print statement, because if I don't have that visual cue telling me where the script is at, I won't know how close we are to completing this program. And this is very important because the tables have to update in our database, which we will cover later. But if this program isn't done running by the time the database updates, then we won't have the newly updated information. All right, once our loop is done, I'm then going to do a bit of data manipulation. So the first thing that you see here, and ignore the warning, I was running the program earlier and I just had to interrupt it because it takes a little while to run. So the program runs, I just had to stop it from running because I was going to look at something else. So with this next block of coding where you see b published equal pd 2 underscore date time, we are going to convert that published column to a data type of date time. And then in the next line of coding, we are still going to continue to work on the published column, but we are only going to retrieve the date for it. This is because when we converted it to date time, the column includes the date and the time. I only want to look at the date for the article link, and so that's why we converted it. So that's why we only pull dt.date. This will return only the date value for that specific article. And then lastly, we are going to export that data frame to a CSV file at this file location path. And the file will be named stock_news.csv. So now I'm going to show you what the dataset looks like. This is not the final dataset. We still have a bit more work to do for this dataset, and we're going to cover that in a later video or later down the road. Alright, so you can see that we have our index column, then we have our stock symbol column, the headline for the article, we then have the link and the date it was published. Now in Excel, you could click the link and it'll take you directly to the web page. But this is not the final version of the data set. Like I said earlier, there's one thing I need to remove, and that will be the index column. And quickly, I could show you what the final data set for the stock underscore news looks like. So in the end, the file gets renamed to stock news and the format of the file is changed to Microsoft Excel 97 to 2003. This is a automatic data cleaning process. So whenever the macros VBA file, which cleans all my data sets, is open, all of the data sets are updated, cleaned, and can be used to update the database. So as you can see here, the index column has been removed. We still have the stock symbol, the headline, the link, and the date the article was published. And as I was mentioned earlier, if you click on the link value, it'll take you directly to the web page. But in Excel, you gotta click inside of the cell, then outside, then back in, and then it'll recognize it as a hyperlink. But in our Power BI report, we don't need to do this. We just click the headline and it'll take us to that article link. So you can see I clicked the link and it's taken us to our article link. It's opening the web page and the article comes from the website called marketbeat.com. With that out of the way, we can move on to our next data set. And this one is called, or our next script, excuse me. This one is called stock underscore sector underscore scrape. The website we are going to be using is Fidelity, and we are going to take the sector and the industry from this web page for every stock symbol in our data set. This is where things may get a little bit complex because now we are using another website to look at stock symbols as well. So Yahoo Finance might have all of our stock symbols, but when we come to the Fidelity website, we may find that a few are missing or Fidelity just don't have them at all. And so we have to solve this in our script as well. The reason for me pulling each sector and industry is mainly because I want to look at a group of stock symbols that belong to a sector or industry and how they perform as a group. Although every stock symbol is not listed, I still think you could get a good idea of how each sector and industry performs with the stock symbols that we have in our data set. Alright, so we could get back to our script. So for our script, we are still using the same packages and libraries as the previous data set, the Google News web scrape one. And it's basically the same concept, so this one will be a little bit faster. With the first box, we are going to import our packages and libraries again, and then we could quickly move on to the second box, will take us to where we are reading in our file. And this contains the stock symbols and the company name behind it. Moving on to our loop or our loop coding section, we first create a empty data frame on the outside of the loop. This is where all of our data will be held. So we can move on to the loop now. So for symbols in stock underscore symbol, we are going to do a try, accept, and pass. This is because not every stock symbol is listed on the Fidelity website that I have in my data set. So it's fine with me if the loop just skips over it and move on to the next one that is in the Fidelity website. For the try, accept, the try is going to try and run the loop, and then if there's any errors, the accept portion, in our case, will pass on to the next stock symbol. So the program will continue to run instead of being interrupted. So now we have our URL link, and this is going to search for all of our stock symbols in that file we loaded earlier and hopefully retrieve the sector and industry if it's available. A very similar concept to the final news scrape file, where we are able to modify the link and have our symbols automatically put in there. On the Fidelity website or with the Fidelity link, they have a portion where it says symbols equal and then whatever stock symbol you want to put in there. In our case, we could do this automatically by just putting symbols. Then after the URL variable, the next 3 lines of coding are going to search for the web page, read it, and then close it. Once all of that have been completed, we are then going to use a HTML parser to read that web page or to find the information we need. Then we are going to use Beautiful Soup to find the tag of span with the attribute element of class where the attribute value is equal to right. This information holds our sector and the industry. Once we have that completed, we are then going to set up a variable called sector, and this is going to look at our table with the index of 2, and it's going to retrieve the text. This is going to retrieve the text for the sector. So if it was WBA, the sector for WBA is consumer staples. The next variable that we created is called industries, and this is going to look at that same table but with the index of 3, and it is going to return the text of the industry. And for WBA, it is food and staples retailing. We then will create a empty data frame using the index as our symbols, and this will be called A. Within that data frame, we are going to create several columns. Their names are stock underscore symbol, which is equal to the symbol the current loop is on, the sector, which is equal to the sector variable, and the industry, which is equal to the industry variable from earlier. I also have the sector variable listed again. You do not need to worry about this, so we can move on to the next line of coding, where we have our data frame that's inside of our loop, which is going to append to our data frame on the outside, to our empty data frame. And that information is going to be continuously updated to our B data frame. So that'll hold all our stock sector and stock industry information. And like I said, again, moving on to the next line, we have an except. When I was running this program before, I was getting errors midway through the program. So I came to realize that not every stock symbol is listed on the Fidelity website, or it may be written a little bit different, so it's not gonna find that web link. And if that's the case, then as I said earlier, it could just skip it. I have a SQL query later on that I will show you guys, and it shows you which stocks were not found in the Fidelity website, and it's also included in the front page of the Power BI report. And this is what the data set looks like. Again, it's not final. We need to remove the index column, but it's pretty close to the final version. And if you scroll down to the bottom, the earlier example I was talking about, WBA, you can see consumer staples and food and staples retailing. So everything looks correct on this page. And we also will export this data set or data frame to the specified path as a text file. The reason for this is just because just to switch up the formats of the file. So when it comes to creating our database or creating an ETL pipeline, everything will be different, having some diversity in our files or probably make it a little bit challenging. So now I will show you what the final data set looks like for this stock sector industry scrape. So once I open up the macro VBA file, which is a file that cleans most of my data sets, the file gets changed to Excel 97 to 2003, and the index column is removed from this file. That's basically about it. And there's a reason for this, because when we perform the ETL process using SSIS, not every file that I use worked with SSIS, so I had to change the files. Alright, I know I said that the Google News scrape was probably the most difficult one to complete, but the Fidelity benchmark scrape, now that we've come across it, I would say takes the cake. A very simple table, but it took a while to try and figure out how to solve everything, and I'm going to show you what the table looks like. Alright, so this table also comes from the Fidelity website as well, and we are taking a look at the sector. So this table is going to show you whether the sector has increased or decreased over a certain time period. And the time period options that we have are last percent change. So the last time that you open up the table, we have a 1 day period, 5 day, 1 month, 3 month, a year to date period, 1 year, 3 year, 5 year, and a 10 year period. Originally, I was not going to scrape this table, but after realizing how important this information is, I decided to give it a try, and it was a very challenging table to scrape. This table will probably serve as a guide as to what stocks I may pick next, depending on the results of this table or which sector is performing the best over a certain time period. But without any further ado, let's get on to the script and what I've completed so far, or what I was able to do. Okay, so I was able to successfully scrape this table, but let's go over the script and how I did it. So we already seen these packages before. We're going to use URL lib and URL open, as well as beautiful soup, request, pandas, and numpy. And then onto the second box of coding. As always, we are going to read in our stock symbol name text file. This contains our stock symbols and the company name behind it. Now let's move on to the third block of coding, and we have our URL. This URL takes you directly to the table that we seen earlier, and there's no need for modifying this table. This table is updated constantly on the Fidelity website. So whenever you click this link, it'll take you to the table, and the numbers should change depending on if the stock market was open or closed, because the stock market is always constantly changing during it's open. So next, we are going to set up a variable called uClient and send a request through our variable URL. And then we have another variable called HTML. This is going to read that request we sent, and then it's going to close that web page. Once it closed the web page, we can now try and parse the web page using a HTML parser. So this is nothing that we haven't seen before. It's basically going over the same process of, the beginning stage of scraping anything from the web. Alright, to move on to the next block of coding, I just want to give a heads up that every line of coding is not necessarily needed in this script, but I was just trying different things out to see how I could get this program to work. And so some of the codes in this script are not necessarily needed. This will affect performance, but I don't think it really matters here because the table we are dealing with is so small and there aren't that many data values. So let's move on to the fourth block of coding. So we are going to create a variable called table, and this is going to web scrape that whole table we seen on the Fidelity website. With that table being scraped using the find all method, we are then going to set up another variable called table underscore data. And this is going to look at our table variable with an index of 0 because we only have one of the historical performance list table, and it's going to look for all the tags that have tr, which I believe is table row, and a attribute element of s value, and it is going to be equal to .gspt. Then we have a last variable called table underscore values, and this is going to look at our table variable again with the index of 0 because this is the only table that Beautiful Soup was able to scrape. And we are going to look for the tag of TD, which I believe is table data, with the attribute element of class and the attribute value of positive value or negative value. So the last two lines of code in here are just for example purposes. The second to last line of code that I have here is basically going to scrape the sector name from the Fidelity website. .gspt is related to information technology. And then the last line of code in the coding block of 4 for table underscore values is going to find the table data for the information technology sector. In the Fidelity table on their website, each value is associated with a positive value string or a negative value string. There are several more options as well as positive value last child and negative value last child. But currently we are focused on this example here. So we have the second to last line pulling our sector name, and the last line of coding in block number 4 is going to pull our data values. As mentioned earlier, those last two lines of coding are just for example purposes. But the first line where we have the table variable, that is the most important line out of all of that coding right there. The next block of coding, which is block number 5, is useful, but it's outside our loop. So when we go to create our loop, those 3 lines of coding that you see in block number 5 will be used in our loop. And I'll go over what block number 5 does. So we have a variable call or column, we are going to call it. We have a variable called column, and it's going to look at the table index of 0, and it's going to find all the tags of A with the attribute element of href and the string of JavaScript void. What this basically is our column names. And then we overwrite the column variable to look at. Then we are going to overwrite our column variable, and it's going to be equal to column with the index of 0, and is going to retrieve the text. In this case, it is going to pull the text of sector name. That is one of the columns in the Fidelity benchmark table that we viewed earlier. After that, it's then going to do a bit of data manipulation or data cleaning. So we have another variable called column cleaning, column underscore clean, and it's going to replace the new line with a empty string. After it removes the new line with a empty string, it's then going to replace the empty space, if it finds any, with a empty string, or it's just going to delete that empty space. The reason for this is that when I went to go pull the column names, they did not look right, and if I were to put it in the table, it would ultimately mess up the table and wouldn't really serve a purpose. So using the replace function twice cleans up this data and makes it more readable. And block number 5 is a very similar concept of what we are going to be using in our loop in coding block number 6. So on to the next section of the code. And this is a very similar concept to what we've seen before, but things have slightly changed. So the first thing we are going to do is that we are going to set I equal to 0. And this section of the coding covers our columns. So first we are going to grab the columns from that Fidelity benchmark table that is already in the Python environment. So we set up another variable called calls, or we could just call it columns, and it's going to be equal to a empty list. Think of this as the empty data frame that we made in previous scripts. So calls is a empty list. Then we will begin our loop. So for columns in call, we are going to perform these steps. While I is less than 11, and we set I less to 11 because there are 11 columns. We don't want to go over, or we don't want to undershoot. So while I is less than 11, perform these steps. We are going to create a variable called call, and it's going to look up the table with an index of 0, and it's going to use the find all method to search for the a tag, the href attribute element, and with the string of JavaScript void. This is our column names right here. So then what we are going to do is we are going to overwrite the column variable, and we are then going to say, give me the column index for the current position the loop is on, and only retrieve the text. So to make it a little bit easier to understand, where we have column in square brackets I dot text, we are only going to retrieve the column name the loop is on. So if the loop is just beginning, we have I equal to 0. So the first column in that fidelity benchmark table is sector name. So the first column, or the text that we should get returned, is sector name. And then moving on to the next line of code, which we have is column underscore clean, we are going to clean that column name and make it more readable for the end user. We are then going to create another variable called column clean test and set this equal to the column clean. And then after that, we will append that to the columns list on the outside. And then after that is done, we will add 1 to I. So in our case, if 0 is done, we're going to add +1. Now we are on to I equal 1. And if I reaches 11, we want to break the process and stop. Then we will create a empty data frame where our column names is equal to that column list. So now that we have our column names, we can now go after our data values. So in block number 7, we are going to start with I equals to 0 again. And then we are going to create another empty list, which will be called data1. After that, we will create a variable called data, which will look at the tag of td, which is table data, and then with the attribute element of class, and then all the possibilities that a table data could have, which is align left, positive value, negative value, no change value, positive value. I also believe negative last value child and positive last value child. This right here, I had to search on my own, or I had to look and expect how many different possible outcomes can a table data have for this particular table. So on to the loop now. So for data underscore values in data, we are going to perform these next steps. While I is less than 132, we set I less than 132 because we have 11 columns and 12 rows of data. 11 times 12 is equal to 132. So once we hit 132, we should have our complete table, and that is included with the sector name as well. Then we are going to create a variable called data, which we have seen before, and this is going to grab all our table data. So from the sector name to the value for a 10-year period, all that data is going to be grabbed. Then depending on the current position I is on, in our case, since we haven't started a loop, I will be on 0. We are only going to retrieve the text. Once we have retrieved the text, we are going to create another variable called data underscore clean, and it's going to go through that data cleaning process that we went over earlier. It's going to remove the new line and replace it with a empty string. And then if there's a space that we can't see, it is going to remove that space. After that, we create another variable called data underscore clean underscore test, and we are going to set it equal to data underscore clean. Once that is completed, we will append data underscore clean underscore test to the list on the outside, and that variable is called data1. After all that is said and done, we will add 1 to I. And once we do this 132 times, we are going to break the loop. And because our data is in the form of a list and not a data frame, we need to reshape the data. So we are going to use a NumPy function called reshape, and we are going to reshape data1, and then we are going to have the table rows of 12 and the columns of 11. We have it set up like that because that is how the fidelity table is set up on their website. After we have reshaped the data, we are then going to call our df data frame. We are going to call all the columns, and we are going to set it equal to data1. So that way we are plugging in the data1 data into our data frame of df. Once that is complete, we will then export that data frame to a CSV file while setting the index equal to false. And the name of the file will be called fidelity benchmark. But this table still needs a little bit of more cleaning, and we are going to cover that once we reach the macros VBA file. And I will show you what the final dataset looks like for the fidelity benchmark table. The table looks exactly like the one you see on the Fidelity website. The only thing we really had to do was replace a couple invalid characters with a 0 and remove some text from the sector name. But other than that, this table is basically the same thing that you would see on the Fidelity website.